What exactly happens when you go to play a Netflix or an Amazon Prime or a Peacock video, whatever platform you're working on, or maybe you're using your Roku or your Amazon Fire and you want to watch something YouTube, watching this video for example, what happens in the background, the things that you don't see. Because for you, you might just be using a remote or using your mouse and you're clicking play, but there is so much that is happening just by going to a service and playing a video, accessing a website, so many different things. We are going to be talking about today what exactly is cloud infrastructure. It is so popular with all this AI and data centers being popped up. I wanted to give you guys an overview of what is cloud infrastructure. So, welcome to another episode of Software Explorations Concept and Overviews, hosted by yours truly, Techo Droff, where we are engineered to win. We're going to be diving deep into this cloud infrastructure, give you guys an overview, get a better understanding of how everything works. All right. So, with that being said, let's get to it. We're going to be part of our agenda today. We're going to be going through the key components, how they work, the major providers for cloud services, and different use cases. All right. So, let's jump right in. Let's talk about what is cloud infrastructure. Cloud infrastructure is virtualized computing resources delivered over the internet. So basically, you have servers that are servers that are hosted in another location, and those servers can be doing part of the core components. Virtual machines where you can log it, where you can have a Windows computer, a Windows server. You can have a Linux machine. You can have Mac machines. You can have different. You can have them with different softwares. They can do pretty much whatever you need them to do. They are hosted in a off-premises location, and you have containers for like to run Docker image, to run Kubernetes. That's the compute aspect of it. Then you have storage, which is, for example, AWS S3, where you can store all the files that you want. So, for instance, it's like having external hard drives all over your office, but instead of storing them on these servers, these external hard drives, you are storing them in the cloud, so that in S3 you can retrieve all your files from there. Then we have networking, so our virtual private networks, our DNS, our load balancers, where we set up our subnets, where we set up our routing, all of that. So now, if we take a look at this diagram, there's different type of services and softwares that are offered. So we have infrastructure as a service, we have platform as a service, and we have software as a service. Let's break down each of these. So as you'll see for infrastructure as a service in purple, or is that pink? I guess it's pink. So part of the infrastructure as a service, you have virtual machines, storage, and network. Those are part of the infrastructure. So you have your machines that are running that can run the application, the storage to store data. You have the network configuration, that's part of that. Then it goes into the inside, like on the infrastructure, you have the platform as a service, which is going to have your runtime, have your middleware, have your operating system. Is it running on Linux? Is it running on Windows? All of that. And then you have your software as a service, which is going to be the actual application that is being installed on the platform, and the platform is running on the infrastructure. So that is the correlation between the infrastructure, the platform, and the software. Now, if we take a look at the key building blocks for cloud platforms, the compute service we already touched on a little bit, but we have the virtual machines. So for AWS, they're called EC2 instances. You can spin one of those up. I would say if you haven't done so already, I highly recommend you go and you start up a EC2 instance, log into it, and practice some of your Linux commands, because that way you get to get hands-on with actually starting up a cloud virtual machine, and then you get to practice some Linux commands on there. We have Azure virtual machines. And now for containers, we have Docker, we have Kubernetes. We work on this extensively on Sundays. We spend a long time using Docker. Then we've been spending a long time using Kubernetes, but also Kubernetes and Dockers, they go together. Another compute service that we have serverless. So for instance, you can do computing in the cloud. You don't have a particular server. So that would be done by AWS Lambda, which is something that we definitely need to get into. We have Azure functions, which are also serverless. Now let's go into our storage options. Very, very important. Object storage, we have Amazon S3, and Azure Blob. That's an interesting name. We have block storage, EBS, and we have Azure Disk. And then for file storage, we have EFS. So that's, I guess it would be EBS is elastic block storage, and then for EFS is elastic file storage, and then we have Azure Files for that. And then lastly, we get into the networking. For networking, we have the virtual private cloud, VPC, or can also be called virtual private network. We have the load balancers, which they will be routing traffic based on the amount of, like, let's say you have an application that gets so much traffic. You're going to have load balancers to distribute where that traffic is going so that the application doesn't crash. We have firewalls and security groups, which are very important because they prevent people from accessing certain ports. And it also says, all right, these are like the security groups say, okay, people who are part of this security group or not people, but machines that are part of this security group is going to have access on this port, on that port. So that way you don't have to create a different security setting for every single server that you're running. You can say, all right, this server right here, it should have security group A, and this server right here should have security group B. And they have different permissions based on where you're coming from, based on things of that nature, right? Then we have DNS services. For example, we have Route 53 in AWS. I've used that before in the past. Basically, it's saying if you have a domain name, where do you want that domain name routed to? So you can set up your name servers, or you can set up MX records to point to some type of mail system, or you can use CNAMEs, aliases, at records, all of that to be able to direct how users interact with your application through naming conventions. All right. Now, how does it all work together? Let's get into the provisioning services. So, for example, you have infrastructure as code to set up your infrastructure. We've used Terraform before. We haven't used CloudFormation, but it is AWS's tool that is similar to Terraform. We do plan on getting to it at some point in our future. Now, you also have scaling. You can either scale horizontally in how you are increasing your machines, or you can scale vertically. If so there's that to consider. Now, how you can also automate your infrastructure. For example, you can use auto scaling groups. So that says, all right, if there is X amount of traffic passes this threshold, now we need to add 2 more servers to our auto scaling group. You can use CI/CD pipelines. For example, if you're doing Terraform, you can say, okay, if all these checks pass, go ahead and merge. And once you do the merge, we need you to go and build this Terraform infrastructure inside of a production environment, or you can even do it going from a dev environment to a stage environment, right? And then there's also monitoring tools to see if builds are failing, if see what issues are happening, so that you can monitor the infrastructure to make sure everything's on the up and up, right? Another thing that you want to make sure is that with your cloud technology that you have high availability, and if a disaster does ensue, how do you recover? And that part right there is from taking regular backups of the site or the application, so that if you need to redeploy, if you need to move it over somewhere else, that is a possibility. All right. Now, let's discuss some popular cloud providers and their infrastructure. AWS, Amazon Web Services, one of the ones I'm most familiar with. They use EC2 instances for the virtual machines. They use S3 for their storage. They use VPC, virtual cloud networks, virtual private network, and virtual private cloud for their networking. And then they use they use IAM for their identity and access management. That is basically who gets permission to the site or to the application. From what IP, what ports, things of that nature. No, that is not for the IP or the ports. That is what users have access and authorization. IAM is access and authorization to those. So there's that. And then we have now we have Azure. I have used Azure minimally when I'm coaching some of my tech barbarians, but I have not been very active in Azure. I was able to figure out how to use it though. But for Azure, they're just called virtual machines. The very thoughtful name, virtual machines. We have blob storage, which is equivalent to S3, and we have virtual network, very thoughtful as well, for their networking. Then for Google Cloud Platform, we have Compute Engine. We have cloud storage, and we also have VPCs. And for others, there's IBM Cloud out there, there's Oracle Cloud, and there is DigitalOcean. I have used the Google, a little bit of the Azure, and I have used AWS intensively. I have not used IBM Cloud, Oracle Cloud, or DigitalOcean yet, as a full disclaimer. Now, what are some common use cases for cloud infrastructure? Pretty much everything, but we'll go through a few. Hosting web applications. So, for example, when we first built the Poopy Pants app, that is built using AWS infrastructure, where we had initially built it with Elastic Beanstalk, where we have worked to turn into a Docker application. So we have but at the end of the day, the the underlying premise of the web application is hosted on a cloud environment. We have data analytics and storage. We have machine learning workloads. As part of the machine learning workloads, to me, it's a little bit similar to the large language models that we do in the morning. And one of the things that I've been thinking about doing is putting on, for instance, a Olama, running an Olama on a EC2 instance, in order to be able to have more interaction with that large language model, because when I run on my computer, it runs super slow. All right, DevOps and CI/CD environments, and we have enterprise IT modernization. Those are the common use cases, right? So, what are some benefits and challenges to migrating to the cloud? The benefits: it is cost efficient, pay as you go, and let me explain this: pay as you go. You pay for what you use. So if you use a lot, you're going to pay a lot more. If you don't use a lot, then you're not going to pay that much. And here's the idea behind it. When you are building out a data center, in whether it is on-prem or off-prem, you're going to have to buy all the equipment that you need up front and pay for whatever cost is associated with that. But with the cost efficiency of pay as you go, you only pay for what you need. You're not buying a physical router or a physical server, all these type of things. AWS has all those things set up, and they're able to allocate for you space in order to use it on their platform. Another benefit is scalability. So you're able to expand it and shrink it quickly as needed. And then lastly, for the benefit, you have flexibility and speed. You're able to work a lot faster. Let's say you want to spin up a whole application. You can probably get it done in a few hours, compared if you were to do it manually. You have to wait for infrastructure to come in, all this different type of stuff. All right. So what are some challenges? There is vendor lock-in. That's a big problem. That's a big challenge. Why is that a challenge? Because a lot of times we end up going for what is easy and expedient instead of what is meaningful. So we end up getting stuck into a particular vendor, and now when we want to change, we're so integrated, and the vendor we're changing to, they don't import the way that the other. It's just a mess, right? So one of the challenges is being stuck to a vendor that you want to switch from, and there's nothing you can do because there's no one who is able to uncouple yourself from that vendor. Security and compliance. When you're dealing with these cloud infrastructures, you always have to make sure that their criterias are meeting a certain standard. Because guess what? If you're using their application and their criteria are below standard, and someone goes to your website, your application, and gets affected by it, then that means you failed the security and compliance as well. Complexity at scale. You're able to do a lot. The challenge is the complexity at scale. You're able to do a lot. However, the bigger it gets, the more hoops you got to jump through. Let's say you end up having like 30 servers, and it just makes it a little bit more complex to manage each of those servers that are up and running. All right. What about the future trends for cloud infrastructure? So AI integration and infrastructure management. So how are we going to get AI to help us create this stuff? Is it going to automatically start spinning up these instances, or is it going to be getting the template to set up these different infrastructures that we need, right? So because we can set up the template, we can use AI to write it and do all that, but is it going to be just having robots come in to do that type of work for us, right? Future trends is going to include edge computing and multi-cloud and hybrid cloud strategies. How to use all of those to give you a better outcome when you are trying to get a better grasp of this cloud infrastructure, what's going to be stored, what's not going to be stored, what is the EC2, what is the hosting, what is the load balancer type stuff. All those have to be taken into consideration. All right. So final thoughts. Pretty much we went over what is cloud computing, why is it important, and some of the pros and cons to it. We spoke about real world impacts of cloud infrastructure. And I encourage you that you continue to learn about the cloud. And I'll say this about the cloud, right? There is a big push in the US to open up data centers. And guess what? They're going to need people to be able to effectively run these data centers and have a good understanding of how all these concepts work. You're gonna have to be provisioning these virtual machines, these EC2 instances. You're gonna have to provision these name services, these networking services. There's so many things that you need to do in order to be cloud certified, but also fluent in the terminology and the documentation and how to make things happen. All right, but that is all. If you have any questions, feel free to drop them in the chat, or not in the chat, but in the comments, and I promise to get them answered for you. Because I'll tell you this, the cloud is where things are moving to. Every day you see more and more companies are moving towards a cloud-based technology. All right, so let's wrap it up for today. Thank you guys so much for tuning in. I truly appreciate you. I just wanted to take the time to give you a better understanding of what this cloud technology is, because we are always talking about it. We are always working on it. But I don't think we gave a sufficient breakdown and explanation of what it is. All right. With that being said, do me a big favor on your way out. Like the video, share the video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content. As well, go to techcoachralph.dev, where you can sign up to work with me one-on-one. You can get access to exclusive content, how I use my calendar, see the sprint reviews and the scrum nights that I do with my tech barbarians. You can even become a tech barbarian yourself if you need one-on-one coaching to help you level up in your tech career. Go to techcoachralph.dev, sign up today. Do not hesitate, and we can go from there. All right. But with that being said, I'm going to get out of here. You guys have a wonderful rest of your Wednesday and a wonderful rest of your week. Tech Coach Ralph, we are out.
We slanging massive code.
We slanging massive code.
We slanging massive code.
We slanging massive code.
Learn the code while the city slept tight. Now I'm slanging lines that spark like late night. From Python webs to TypeScript skies, React in my veins and APIs that rise. Keyboard clacking, I'm stacking gold. Syntax flows like stories untold. Drinking caffeine, I'm breathing in code. From morning dawn till the night unfolds.
My code goes long. My code goes deep. Caught in the stream where the data don't sleep. Need my digits. Better call my line. Slanging massive code like it's story time.
In the hustle jungle where the bites meet steel. Digital canvas where I paint and feel. JavaScript whispers in the code I weave. Tech dreams blossom in the lines I conceive. Lines so slick they can't be caught. Variables twisting every plot. Python powers every thought. JavaScript legit hitting the right spot.
My code goes long. My code goes deep. Caught in the stream where the data don't sleep. Need my digits. Better call my line. Slanging massive code like it's story time.
Stacks on stacks, build my empire tall. Debugging dreams where the errors fall. Lines of brilliance break the darkest night. Script so dope, you can see me in the light. TypeScript magic on my fingertips. React's a canvas where logic flips. API dances, syncing clips. My My code's a song where data drips.
My code goes long, my code goes deep. Caught in the stream where the data don't sleep. Need my digits, better call my line. Slanging massive code like it's story time. We're slanging massive code.
We're slanging massive code.
We're slanging massive code.
We slanging massive code.